Hello, this is Mr. Miller, and I hope you're in the mood for some math. In this video, we're going to do some examples related to probability models and expected value. And the goal is to give you some examples so you can complete the assignment that's in Google Classroom. All right. Well, we're going to explain what a random variable is and what a probability model is. And I think the best way to do that is just to jump into an example and give you an example of one. So we're going to consider a spinner game. Very simple. You spin a spinner and it randomly lands on a number, and whatever it lands on, that's what you win. So the amount you could win is an example of a random variable. It takes certain values with certain probabilities. For instance, in this spinner game, there are three possibilities. You could lose $10. So if you land on the negative 10, that means you lost 10 bucks. You could win $20, so that's good news. And even better news is you could win $30. These are the values you can win. There are three values, there are no others. So this is an example of a random variable. You can win negative 10, 20, and 30 with certain probabilities. Okay, so these are the values that the random variable can have, and what we're going to write are their probabilities. So the spinner is divided up into 6 equal parts. There are 4 parts that have negative 10, so there's a 4 out of 6 chance. And you can write 2/3 if you want. There's a 4 out of 6 chance of losing $10. There's 1/20 out of 6 different possibilities, so your probability of winning $20 is 1/6. And the probability of winning $30 is 1/6. This whole thing is an example of a probability model or distribution. When we list the values you could win, the values of a random variable, and their probabilities, that's called a probability model or a probability distribution. Okay, so a random variable takes certain values. If you list the values and the probabilities, that's a probability model. That's basically what you need to know about that. Now, we would want to know, on average, how much we'd expect to win or lose playing this game. So if we played it many times, what on average are we going to win each time? Well, there's a formula for expected value. So expected value, there's several different symbols for it, but I tend to use the capital E for expected. And we put what random variable we're talking about, X, the winnings you could win. So to compute what you're going to win on average, you have to add up the products of the values you could win times their probabilities. So in this case, it would be negative 10. That's the first thing you could win, times its probability, 4, 6, plus 20 times 1, 6, plus 30 times its probability, 1, 6. And if you do that, you're going to get a decimal, but you would find that on average, you would win $1.67 in the long run. That's kind of like the theoretical mean. You play this game a bunch of times, and in theory, this is the average of what you would get, $1.67. Now, that's good news because you're winning. If it were negative, that would be bad news. All right, so here's another example. We have a 6-sided die, but instead of the numbers 1 through 6, it has these numbers on the faces. Okay, well, whatever you roll, that's what you win. So this is only good news. We can only win here. We can win 10, 20, 30, or $45. All right, so let's put down what we could win. These are the values of our random variable. We can win 10, 20, 30, or 45. And next we put their probabilities. Well, a die has 6 faces. One of them is a 10, so that's 1 out of 6. One of them is a 20. One of them is a 30. And 3 of them are 45, which of course equals a half. All right, so that's the probability model for this simple game. And now we want to compute how much would we expect to get on average. All right, so the expected value. I'm going to introduce another symbol here. It's called mu. We saw this when we did normal curves. Sometimes write mu with a little x by it. That means the theoretical average. All right, so you got to take the values of the random variable times their probabilities. So 20 times 1/6 plus 30 times 1/6 plus 45 times a half, or 3/6. And we get that we would expect to win $19.5. Oops, my bad. I'm getting ahead of myself. We'd expect to win $32.5 by playing this game on average. All right. Now, some facts about probability models. First of all, probability cannot be negative. Each probability has to be greater than or equal to 0. Also, probability values have to be less than or equal to 1. So any probability we have has to be in between 0 and 1, and it can include 0 and 1. The last fact is that the total probability is always equal to 1. So we're supposed to decide if these are valid probability distributions or models. Well, the first one, I'm sorry to say, is no, because one of the values is negative. That can't happen. On the second one, all the values are greater than or equal to 0 and less than 1, so that's very good. But the problem is they don't add up to 1. I believe they add up to 1.18. All right, so this one is no. All right, take a look at this one. All the values are in between 0 and 1. And if you add them up, sure enough, you get 1.00 exactly. This is a valid probability distribution. All right, we're ready for our last example. Here, we want to find the missing value. We're told that this is a probability distribution, but we're missing a value. Whenever we're missing one value, we can always find it because we know that the total is supposed to be equal to 1. So if we do 1 minus 0.5 minus 0.15 minus 0.15, this last guy, you end up with 0.20. So 0.20 is the missing value. And now we can compute the theoretical average. We don't know if this is a game or not, but if this is a game, this would be how much we'd expect to win. So we're going to get expected value of our random variable x equals 10 times 0.5 plus 20 times 0.20 plus 30 times 0.15 plus 40 times 0.15. And it turns out this time you get 19.5. Okay, that's our spiel on probability models and expected values. So hopefully now with these examples you can complete lesson 7.2, probability models and expected values, located in your Google Classroom. Take care.